Picture this: you are building a web application that needs to fetch user data from an API, then pull their recent orders, and finally calculate the total spent. If you try to do all of that in one straight line with JavaScript, the browser just hangs, waiting for each step. That is where asynchronous programming comes in, and the two biggest tools we have are promises and the async await syntax. But which one should you use, and more importantly, why do you even need both? Let us break it down in a way that actually sticks. First, we need to understand the problem that promises and async await solve. JavaScript is single-threaded, which means it can only do one thing at a time. When you make a network request, read a file, or set a timer, you do not want to block the entire application while you wait. In the old days, we used callbacks. But callbacks lead to what we call callback hell, code that looks like a pyramid of doom, deeply nested and impossible to read. Promises were introduced in ES6 to give us a cleaner way to handle asynchronous operations. A promise is an object that represents the eventual completion or failure of an asynchronous operation. It is like a placeholder for a value that you do not have yet. You can think of it as a receipt from a coffee shop. You place your order, get a receipt, and later you use that receipt to pick up your coffee. The receipt is the promise, the coffee is the resolved value. Now, promises have three states: pending, fulfilled, and rejected. When you create a promise, it starts as pending. If everything goes well, it becomes fulfilled and you get the value. If something breaks, it becomes rejected and you get an error. You handle these outcomes using the .then method for success and .catch for errors. For example, fetch returns a promise. You call fetch with a URL, it returns a promise that later resolves with the response object. You chain .then to parse the JSON, then another .then to work with the data. This is already way cleaner than callbacks, but it is not perfect. When you have multiple dependent asynchronous tasks, you start chaining a lot of .then methods. The code flows from left to right, then down, then right again, and it can still feel a little messy, especially when you add error handling with .catch at the end. Sometimes you need to handle errors at different stages, and that makes the chain even longer. That is where async await enters the stage. Introduced in ES 2017, async await is syntactic sugar built on top of promises. It allows you to write asynchronous code that looks and behaves like synchronous code. You declare a function with the async keyword, and inside that function you use the await keyword before any expression that returns a promise. The await keyword pauses the execution of the function until the promise settles, and then it gives you the resolved value directly. This makes your code read from top to bottom, just like a normal synchronous script. No chaining, no nesting. But here is the crucial thing: under the hood, it is still using promises. Async await does not replace promises, it just gives you a more readable way to work with them. Let us talk about real-world use cases. Imagine you are building a dashboard that shows user details, then their recent posts, and then comments on those posts. With promises, you would do something like fetch user, .then, user equals fetch posts, user.id, .then, posts equals fetch comments, posts, 0.id, .then, comments equals a display, comments, .catch, handle error. This works, but if you need to add a step in the middle or handle an error for just one of those steps, you have to restructure the chain. With async await, you just write a try-catch block around the whole thing. You assign each result to a variable in order: const user equals await fetch user, const posts equals await fetch posts user.id, const comments equals await fetch comments posts, 0.id, and then display comments. If any of those await expressions fails, the catch block catches it. It is so much easier to debug, maintain, and reason about. But async await is not always the right choice. Promises have some strengths that async await does not directly replace. For example, if you have multiple independent tasks that can run in parallel, like fetching data from 3 different APIs at the same time, you should use promise.all, which takes an array of promises and returns a single promise that resolves when all of them are done. With async await alone, you would write each await one after the other, which would be slow because they run sequentially. You could use promise.all inside an async function, but that is still using the promise API. Another case is when you need to handle a stream of events or a pattern like a race condition. Promise.race lets you get the result of the first promise that settles. These are patterns that the promise library handles natively, and async await does not have a direct parallel for them. Now let us look at common mistakes and pitfalls. One of the biggest mistakes beginners make is forgetting to use await inside an async function. If you forget await, you get a pending promise object instead of the actual value. Your code will not crash, but it will not work the way you expect. Another mistake is trying to use await outside of an async function. That will throw a syntax error. You cannot just use await at the top level of your script, unless you are in a modern module environment. Another pitfall is mixing error handling styles. If you are using async await, you should use try-catch, not .catch on the same promise. Mixing them leads to confusing code. Also, do not create promises manually inside an async function if you do not have to. The async keyword already wraps the return value in a promise, so you can just return a value directly. One more trap, using await in a loop. If you await inside a for loop, each iteration waits for the previous one to complete, which is often not what you want. If the operations are independent, use promise.all with an array of promises instead. Lastly, be careful with error propagation. If you have a chain of await expressions inside a try block, one failure will jump to the catch and stop the rest. That is usually what you want, but sometimes you want to handle errors individually. In that case, you can wrap each await in its own try-catch, or use .catch on the underlying promise. So which one should you use in your projects? The answer is both. Use async await as your default for most sequential asynchronous code because it makes your code cleaner and easier to read. Use promises directly when you need parallelism with promise.all, race conditions with promise.race, or when you are working with libraries that return promises and you want to chain simple transformations. The beauty is that you can mix them freely. You can create a promise with new promise inside an async function, or you can await a promise chain. The JavaScript engine does not care. The goal is to write code that humans can understand. Let me give you a quick best practice pattern. When you are building a function that fetches data, declare it as async inside, wrap the core logic in a try block. For each API call, use await. If you need to fetch multiple things at once, gather the promises in an array and use const results equals await promise.all array. Then handle errors in a single catch block. Log the error or show a user-friendly message. And do not forget to return the final value. This pattern scales well from a small app to a large production system. To wrap it all up, promises and async await are not enemies. They are teammates. Promises give you a robust foundation for asynchronous operations, and async await gives you a beautiful layer on top that makes your code look like a simple recipe. As you grow as a developer, you will learn to use both naturally. Start with async await for most situations, and reach for the promise methods when you need to handle multiple simultaneous tasks. The more you practice, the more intuitive it becomes. If you found this breakdown helpful, please hit that like button, and if you want to keep leveling up your JavaScript skills, subscribe to Dev Brief. We break down complex tech topics into clear, practical lessons every week. Thanks for watching, and happy coding.